Welcome back. In this video, we're going to be looking at the index law that helps us simplify quotients that contain factors with common bases. So the law states that if we have a to the power of m divided by a to the power of n, we can simplify this down to being a to the power of m take n. So what we do is we get our exponent in the numerator and we subtract the exponent in the denominator from it. So it's going to be the difference between m and n. So factors of common bases can be simplified by subtracting the exponent of the denominator from the exponent of the numerator. So what we've got is a rule that allows us to simplify expressions of quotients where we have a common base. Now let's look at a few examples. So in example 1 we have 3 to the power of 5 divided by 3 to the power of 2. What we can do is we can use this rule to write it as, we'll go 3 to the power of 5 minus 2, and we'll grab a little bit more space. And this is going to simplify it down to 3 to the power of 3. Now having a look at why this actually works, what we can do is we can expand out the numerator and the denominator. And what we find is that if we simplify this out, so we take like for like, what we're left with are simply 3 threes left on the top line, which would simplify down to 3 to the power of 3. But when we're solving this question, we'd simply go from here straight down to these two lines here. Alright, example 2, we have x to the power of 7 divided by x to the power of 3. We're going to use this rule to simplify this algebraic quotient here. So once again, we're going to use the rule of grabbing the numerator and denominator. So we put our common base of x, and then we go 7 take 3. This will yield a result of x to the power of 7 take 3 is 4. So x to the power of 4. So nice and easy. Example 3 now. We are dealing with an algebraic quotient that has multiple factors in both the numerator and the denominator. So what we need to do is we need to look or identify the factors that have common bases. So we've got the x's here and we've got y's. Now highlighting, we have 3 and 2. They're on a common base, and 2 and then an implied 1. So what I'm going to write this out as is 3 take 2 and then 2 take the implied 1, like so. Simplifying this out, x to the power of 3 take 2 is x to the 1, and then y to the power of 2 take 1 is y to the 1, and that's going to simplify out to x, y, because the implied, or the power of 1 is implied. Okay, example 4. We have 2 to the power of 2 divided by 2 to the power of 4. What we're going to do is we're going to grab our common base of 2, and then we're going to get the numerator's exponent of 2 and subtract from it the denominator's exponent of 4. What this is going to yield is a rather uneasy case at the moment of 2 to the power of minus 2. So what we've got here is a negative index. When we get a negative exponent, we don't have to panic, but for now we'll just leave it as is because we'll learn how to deal with these in a later lesson. And finally, in example 5, we have x to the power of 3 divided by x to the power of minus 5. Once again, we have an algebraic quotient that we're going to simplify using our rule around division. So we're going to get our common base of x. Our numerator's exponent is 3. Our denominator's exponent is minus 5. So we're going to go minus negative 5. This is going to change into 3, or x to the power of 3. Double negative is going to become plus 5. and therefore the result is going to be x to the power of 8. So in summary, this has been a video demonstrating how we can apply the index law pertaining around the division of common bases.